Hello, good evening, everyone. Able to hear me? Sorry for delay joining. Hello, can you hear me?
Yes,
Yes,
sir.
sir.
Okay, thank you. Okay, we'll start. Okay. Today, what we'll do is we'll take up some band theory of solids. Then see, let me see who are coming here. And then every time I log in, new students are coming, except one madam called Santoshi. She's repeatedly coming and she's listening to the classes. And apart from that, they're all new ones. Okay? Anyway, whatever. Let's have a discussion on the band theory of solids. Okay, we will discuss about the block theorem. This is one of the most critical. I'm openly telling you, this is the most critical derivation usually studied with quantum mechanics. Okay, this block theorem, conical models, but still you have it in the solid state physics. We will make an attempt to understand about the block theorem, and because to understand more about the block theorem, you have to have some idea about the quantum mechanics. Otherwise, it will be quite difficult to deliver. This is quite difficult because you have to know about the Schrödinger's equation, what it is psi stands for, okay, and what is this Schrödinger's equation stands for. Okay, what for we are writing this Schrödinger's equation? It's not just like some mathematics. You do it. You have to have some physical idea, physical derivation, how we are doing it, what makes the equation right, what is the purpose of writing. Don't get carried away by the notations. Most of the students, by looking at the notations in quantum mechanics, they will get carried away by that, and they don't even try to understand. Okay, that's the problem. Though I know that there is some complex in understanding, it's a highly imaginative. Okay, but still we will make to try to understand about the block theorem. Okay. Usually, this block theorem and the chronic penny model both are very important questions from the examination point of view. Usually, it will be given in the questions. Okay, and this topic will be useful for your quantum mechanics also. Okay, quantum mechanics paper also, because the same topics are there in your. Okay, so let's make an attempt. Okay, block theorem. See, first of all, the block theorem is suppose a crystalline solid has been taken, for instance, okay, and the solid consists of lattice, which is composed of large number of ionic cores at regular intervals. This is the case we are taking once again. The solid, so a crystalline solid consists of a lattice, which is composed of large number of ionic cores at regular intervals. And the conduction electrons can move freely throughout the lattice. That is what the thing is we have been talking about. Okay, crystalline solid has been taken, and as you know that they are having ion cores at regular intervals. Okay, and the electrons will be moving much freely, moving freely. Okay, if that is the case, okay, just in case must you take. Okay, don't just enter into the equation. Most of the textbooks usually they don't mention much about the introduction, but instead they will just start with the derivation. That's not right. Okay. So let us assume that the lattice is one dimension. Assume that it is one dimension. Okay, and only on an array of ion cores having, let us say, that they are along x-axis. Okay, and that means we have a crystal, yeah, and we are talking about the ion cores. Okay, they're all being present, and so also the electrons are being present, and we have taken some x-axis. Okay, along the x-axis, the moment we are talking. Okay, so how it will happen, we'll see. Then the potential energy of any body within that field of attraction is said to be here the negative. Okay, and the conduction band is bound to be solid. The potential energy is P is taken as negative. The potential energy is assumed to be taken as negative. And therefore, here what happens says the site of an iconic ionic core. The site of an ionic core. Okay, P is taken as minus infinity. P is taken as minus V is taken as minus infinity. Since this occurs um, symmetrically on the either side of the core, it is referred to as a potential well. Okay, it is. We assume that C is a potential well. It's something like a container. Okay, we assume that it's a container. Actually, it's not a container. Okay, I told you that it's a container. At the same time, telling you it's not. So that's what. The thing is that you have to assume that we have a shape like that. So,
Sir, please tell the page number, sir.
page number, sir. First, listen to madam. First, listen to. Okay, first listen to the
Sir,
theory.
actually, what you are telling, we can't understand, sir. That's why we are asking.
Okay. See, when you first start listening to, no, then you will understand things. Okay, anyway. Okay,
When you are explaining that concept, your voice is getting slow, sir.
is it? But I am able to hear your voice clearly. What's the problem?
Don't know, sir.
Okay, it's actually the band theory is in block 3. Okay, block 3. Look for the page number. Now the text. Because see here, usually I don't follow this booklet, your textbook. Okay, free electron theory. We have here. Um,
It is the unit 9, sir.
yeah, I'll show you. Because see at the time of talking about the electron concentration, carrier concentrations. Actually, I would have told, but I have not told at the time. Purposefully, have left it. Okay, I want to discuss now. Okay, because this is a very important question for your examination. Okay, this is Schrodinger's equation derivation. You have to be much familiar with first of all. Then you will be. Have you done the Schrodinger's equation? Anyone? Have you done this Schrodinger equation derivation, please? Did you do the Schrodinger's equation? Hello.
Sir, Schrodinger equation is explained by Ramu sir.
Okay. So that is in your quantum mechanics paper, right?
Yes, sir.
Okay. If that is the case, then if you have some idea, see page number is 152. Okay, we have band theory, and in that we have here block theorem. Okay, block theorem and talking. Okay, and here see, first of all, to begin with, I told you that the lattice has been taken. Okay, we are talking about the see this the well the thing is been talked about. Okay, it's not a well actually, but it is having the electrons to just come across some kind of a potential. That's how you have to understand. Once again, see, this is a kind of a hurdle like. So how it looks like, see, it is a kind of a hurdle, isn't it? If the electrons are up here, let us say, they are here, for instance, then they have to come across some kind of a hurdle. Okay, hurdle is a kind of a potential. There is no such thing as hurdles or wells or something like that. Please try to understand. This is just an imagination where an electron undergoes some kind of energy. Okay, it is undergoing some kind of energy to overcome this kind of forces, it has to have develop more kind of energy. It has to acquire more energy. Then what the electrons will be in a position to come across this potential and may enter into the other side. Okay, this one maybe here or maybe to the some other. This is what first thing is. Okay, that the though in some textbooks they'll be giving here as a potential wells. They have a topic also on the potential wells. Okay, you have to know about the conditions that how the electron behaves inside and how the potential energy is inside and how the potential energy is outside. Those conditions. That's why I'm repeatedly asking you that if you have done this in your quantum mechanics, then it would have been much better. Okay, and then further. And so what is the potential? So as it approaches, see here, if the electrons are approaching any ionic core, let us say, then it is said to be here minus infinity. Okay, the core B is said to be minus infinity. Then, see here, we have to refer this as a kind of a potential well. Okay, the width of the potential well is, let us say, we take it as a small b. Width of the potential well is taken as small b like this. Okay, the width of the potential well is taken as small b, and v naught is a potential. V naught is said to be the potential. V naught is said to be the potential, and the variation is taken as v tends to 0 as v naught tends to infinity. See, v tends to 0 as v naught tends to infinity. Okay, how we have to understand the width is taken as 0. Suppose if the width is taken as 0 and the V naught will become infinity. If you read this one for 4 to 5 times, but still you don't understand. Can anyone tell if I say that B is tending to 0 as V naught tends to infinity? So what does it mean to you? Can anyone tell? Some idea, please. If I say B is tending towards 0 and V naught is tending to infinity, what does it mean to you? Can anyone just give some answer? Maybe you can assume and give some answer. What it might be. Okay, no one is giving an answer. Oh, well, leave it. See here, if B is tending to 0 means here, if the width has become, let us say this width we are talking about has become 0, okay, then what will happen? The potential will act max. That's what you have to understand. Okay. Suppose see here, the width is becoming 0. Again, I'm going into detail. If you take the width as taken as 0, for instance, that means we are not having a wider opposition. Okay, so that is what the thing is, that the electron experiences some kind of forces in such a way that the width will become 0. If the width has become 0, then the potential is said to be having maximum. Okay, that's what the condition is. Okay, and further we have to assume that we have here the V. Okay, potential has been taken, and further V of X we write here. Okay, V of X is said to be the potential, because we are talking about in X direction. Okay, V of X and X direction, then that will become here V of X plus E. V of X plus A. What is this V of X is equals to V of X plus A? In the textbooks, they will be usually giving a V of X is equals to V of X plus A. You have to understand these things. Okay. See, potential is taken here, V of V, and along this direction we are talking about. And that potential is said to be here V of X plus A. Means that period we are talking. Okay, X is along the direction, and if it is extended to some space, maybe like okay, and then it is said to be V of X plus A over a period, for instance. Okay, I'll show you in the diagram. Then you will be understanding it in a better we have here A, okay, and we have here B, okay, and 0. So that's the period we are talking about, 0 to A. 0 to A is a period, okay? Right. Then we can write here V of x is that we here V of x plus A, and x is some distance we are talking about, yeah, I know exactly. And it is that, see, it's not only just a small distance. Distance means what? Between what and what? Between core and electrons here. Core, between core and electron. Remember this. Core and electron. These details, first of all, you have to know. Then it is better to go for the derivation. Okay. Right. The Schrödinger's equation for an electron in one-dimensional constant potential V naught. Okay, is given by here. I'll write down here d square psi by dx square plus 2m by h bar square. Okay, E minus V naught. E minus V naught. Right? And multiplied by psi equals 0. Okay. First of all, I would like to ask questions here. Now, can you please tell me what does this psi stands for? Can anyone tell what does this psi stands for? Can anyone tell what does this psi stands for? Because it's already done in your quantum mechanics paper, please.
Wave function, sir.
Yeah, it is wave function. Okay, wave function. So, what do you understand by wave function? Suppose if you tell wave function, what does it mean? And what is this Schrödinger's equation represents? First of all, okay. And what does, first of all, to begin with a small question, that what is this wave function is all about? What does it do actually? What we are talking about? First question. Second question is about this Schrödinger's equation. Okay, anyway, don't worry, I'll tell you. See, psi is a wave function. Everyone knows. Most of the people knows. Yeah, okay, fine. It's not enough. See, here, psi is actually can be used in multiple ways. Psi can be used in multiple ways. Remember, just like how we are doing in algebra, how we are using x, we are using x. Okay, we use suppose some variable which you don't know. Then you will be assuming as x. How you are assuming as x, and here we are assuming as psi. Okay, psi is a wave function. Psi is a wave function which can be used in multiple way representation. How? I'll tell you. What? I'll tell you. Suppose say psi, first of all, in quantum mechanics, we use this psi to represent the, for instance, a small and minutest changes. Okay, for instance, we are talking about the electron. We are talking about electron. Electron is moving from one place to another place, and let us say it's been separated by a distance and all. Okay, we are talking. Okay, right. Then see how much electrons does contain some charges. Okay, electron does contain charges. Okay, and while they are moving, they will radiate the energy. That everyone knows. Okay, this variation, how much of the variation with which the electron is moving? Okay, that's what let us say psi is equal. Okay, the psi represents very small variation. Usually we ignore those things. We give an accountability which is given by psi. Okay, in case of some movement, okay, matter is moving, okay, from one place to another place. Let us say radiation is moving from one place to another place. Radiation does contain some particles, okay, and those particles are moving from one place to another place. To represent those particles, okay, some distance to one place, okay, from one place to another place. Schrödinger has tried to give a representation. Okay, he has given some representation. He has given some representation. Okay, that see here. See when the waves go, when the radiation is going from one place to another place. Okay, then the wave can be represented in the form of an equation. second order differential equation, which is defined by dou square psi by dou square psi by dou x square, or you can say d square psi by dx plus 2m by h bar square e minus v naught times psi equals to 0. This is what with which the equation moves from one place to another. This is nothing new. If you have studied in your BSc wave equations, this is same as, but a little bit of change. What? And how I'll tell you. See, in BSc, in your first year, I don't know, somewhere you have studied about the waves. Okay, let us say that the rope has been fixed at one end, has been free at one end, or vibrations bar. So here, generally, how we consider the wave equations has been implemented here, okay, in the form of second order equations, but by using a concept, okay, because the variations are taking place from one place to another place with the displacements, okay, along a particular direction, okay, has been defined by the student. Okay, these things you must know about the Schrodinger equation. So once again, so let me summarize that these Schrodinger equation is the one which represents the radiation going from one place to another place, which represents radiation. So it does contain some energy. Okay, so it does goes with some energy. One point on the point goes with some energy. Okay, and that energy and with the parameters taken here, see that d square psi by dx square. Okay, psi is here and the wave function, the variations of the intensity in of electrons and mass 2m is taken by h bar square. H bar is h by 2 pi is taken. E is energy and V naught is potential times cycles. That's how first you must be very clear in what we are talking. Okay, and then we go for the further. Okay, so further what will happen is the h bar can be written as I said, h bar is taken as h by 2 pi. Okay, and h is Planck's constant as you know, and E is said to be the energy, and V naught is said to be the potential. V naught is said to be the potential. Then it has got this equation, has got the solution. The second order differential equation has got the solution. Okay. Okay. The solution is being given by psi of x is given by E plus or minus ikx, e to the power of plus or minus ikx, and that's equation number 2. Okay, that's the solution. Solution is being given by E. Okay, solution is given by psi of x is equals to E to the power of plus or minus ikx. Okay, that is equation number 2. We are writing first equation as the Schrödinger's equation. This plus I by dx square plus 2m h bar square E minus V naught times I equals 0, where E is energy and V naught is the potential we're talking. Okay, and has got its solution. Psi of x is 1 by E power of plus or minus ikx. Okay, and this is question number 2. And then E in terms of kinetic. Okay, energy E in terms of kinetic is given by E minus V. Okay, and further we write here h bar square k square by 2, which is p square by 2. Okay, so this is what we write here. Kinetic is given by E minus V naught is h bar square k square by 2m is equals to p square by 2. Okay, p square by 2. Where k is said to be momentum of electrons. Okay, where k is said to be the momentum of electrons, and divided by h bar. Okay, right. The time independent solution can be obtained by now what we have to do carefully, step by step. See. Okay, step by step, we have to go. Okay. Before I tell this, I'll tell you the statement. So what is this Bloch theorem statement is? A mathematical statement regarding the form of the one electron wave functions. Okay, the mathematical statement regarding the form of the one electron wave functions for a perfectly periodic potential. This is the statement of Bloch theorem. So that's what I'm telling you. Please try to understand that we are trying to write an equation for the radiation going from one point to the other point. Okay, one place to another place. If the waves are traveling with some energy, then the Schrodinger has given his own way of describing the wave with the help of a mathematical equation, which is Schrodinger's equation. Okay, so that's how they try to give an accountability for a wave traveling from one place to another. Okay, that's the Schrodinger's equation with the solution. Further, what is being done, I'll tell you. They have taken here the time independent solution. Now we have to find out the solution for it. Okay, the time independent solution can be obtained by multiplying psi of x. Have to be carefully watch this. Okay, psi of x with exponent of minus I e minus I e t by h bar minus I e t by h bar. Okay, represents wave propagation. How much it propagates? It propagates with this. Okay, the time independent solution can be obtained by multiplying psi of x to psi of x with exponent of minus I e t by h bar. Exponent of minus I e t by h bar, which represents wave propagation along x-axis. So that's what we are talking about. Then the potential energy of the electrons is given by V of x is equals to V of x plus C. Okay, we write here this as equation 3. V of x, as I said, V of x is given by V of x plus C. Okay, the potential V of x is given by V of x plus C. Okay, because we are talking about a period. Small a is said to be here, you can write small a is said to be a period. Okay, and further, this coordinate equation has been changed to b square psi by dx square. Okay, a small change will make it 2m by h bar square e minus v of x with psi equals to 0. Okay, we name it as equation 4. Now, question 4. Now, can you see this equation 1 and equation 4? What do you find the difference between equation 1 and equation 4, please? In equation 1, we have d square psi by dx square plus 2m by h bar square e minus v naught times psi equals to 0. Okay, that's equation 1. Whereas equation 4 is d square psi by dx square plus 2m by h bar square e minus v of x times psi equals to 0. What do you find the difference? Simple. Instead of v naught, we have here v of x. Okay, has been taken. V of x. And further see, psi of x can be written as psi of x is equals to. Now we are changing. How I'll tell you, e power of ikx uk of x. Okay, this is equation 5 we name it, where uk of x is equals to uk of x plus c. Okay, see this one. Psi of x is e power of plus or minus ikx uk of x, where uk of x is given by uk of x plus a. Okay, once again, we have equation 4. Okay, and the solution is being given by psi of x is equals to e power of plus or minus x uk of x. Previously, we have written the solution, that is equation 2, as psi of x is equals to e power of plus or minus x. Instead, we are writing here, we have to multiply with uk of x. Okay, so that's how we are writing. Then we write the block equation, block functions, and they have got the property of psi of x plus a equals to e power of ik into x plus a, uk of x plus a equals to psi of x is equals to e power of ik. This is another equation, block functions. Okay, the block function. Okay, we define the block function. Block has defined the function. The block function psi of x is equals to e power of ikx uk of x. It has got the property. What? It is psi of x plus a equals to e power of ik into x uk of x. Okay, which is equals to psi of x. Okay, further it can be written e power of ik. So what we are writing is, instead of just psi of x, we are writing as psi of x plus a. Okay, we are extending it to x plus a. That's how you have to understand. Okay, that understand that instead of psi of x, we are writing this as equation. If you just have a look at the previous equation, then you can understand that psi of x plus a is equals to e power of I k times x. Wherever x is there, we are just replacing x plus a and writing the equation 5 and to make it as equation number 6. Okay, that's one step. Then 4 has, if let us say, then if 4 has solutions with the property of 3. Suppose if you have the equation 4, it has got the solutions with the property of 3, let us say. The third equation. What is third equation? I said e of x is e of x plus e. That is the solution. Then the solution can be obtained. That's what the block says. Okay? Then see. For this, what we need to understand is that the Schrodinger's equation is actually the second order differential. That's what I've been telling. Then there are actually two solutions. There are two solutions, two individual solutions. He has named it as g of x and h of x. G of x and h of x. Okay, the Schrodinger equation is a linear second order differential equation, and there are two independent real solutions. Okay, g of x and h of x. G of x and h of x. Okay, g of x and h of x. Okay, I'll share the screen. Just a moment. I'll check it just a moment.
Sir,
Yes, sir.
in that equation, there is H or H cot, sir.
H bar.
H bar. Okay.
Yeah, H bar is H by 2 pi.
Okay, okay. Some differences is there, sir, in your explanation and in our book.
Yeah, that's what. See, madam, first you don't compare. You don't compare, madam. This is quite complicated, I'll tell you. This is quite complicated. First, please listen to what we are talking about. Okay, and see, don't compare one step by step by step. I don't, as I told you, I don't follow your textbook first thing. Okay, see here, the thing is that the professors, while your paper evaluation, I'll tell you openly, see, they don't worry about the notes from where you have written or which textbook you are referred to. Okay, so they will be usually looking for the concept. Okay, see here the whether I approach in a different manner or your textbook has been given in a different manner. If you compare, no, then you don't understand. Okay, first you have to see that what is actually the block theorem is, what is the method in it. Okay, and
Yes,
then
sir.
you can choose it afterwards. They don't come to a conclusion. See, there are two methods. You see whichever is you feel like comfortable, then you can go ahead with that. Okay.
We are comfortable with your explanation, sir, but we have to revise that. We have to
Yeah,
note that.
yeah. I'll
That's
tell you,
why.
madam. See, I'll tell you. See, just so I open this to share it. Okay, what I'm talking. If you see it, then you will understand much better. Okay, I'll show you. Just open it.
Okay, sir. Thank you.
Excuse me, sir. Hello.
Yeah.
Excuse me, sir. Besides our textbook, which one is a reference book is
See,
preferable, sir?
if you have Gupta Kumar Sharma, something like Gupta Kumar or anything, solid state physics by any Indian author, yeah, will do. Okay, if you have single or anything like that, okay, will help.
Okay, sir.
But the foreign authors, see, it's very difficult to understand the foreign authors, as I tell several times to the students, that the understanding the foreign books is a difficult task. Okay, that's another issue.
Okay, sir.
If we have single also will do. Single also will do. Just a moment, please. And the file. Yeah, can you see this? Hello?
Yes, sir.
Yes, sir.
Okay, then it will be better. Okay, right? Yeah, just see that. That's what I'm trying to explain. The first equation. Okay, that's the Schrödinger's equation. Discuss I by dx square plus 2m by h bar square e minus v naught times I equals 0. That's the equation. Okay, Schrödinger. Okay, and further h bar is given by h by 2 pi. That's what I'm telling. And the E is said to be the energy, and V naught is said to be the potential. Okay, and has got the solution. Psi of x is given by e power of plus or minus I k. That's the equation. Okay, equation 2. And E kinetic. E kinetic is given by E minus V naught. E minus V naught. Okay, which is defined as h bar square k square by 2m, which is given by p square by 2, which is given by p square by 2. Okay, and further, of course, k is said to be the momentum of electron. Okay, the time independent solution can be obtained by multiplying psi of x with the exponent of minus IET by h1. Okay, which represents wave propagation along x-axis. Okay. See, the time independent solution can be obtained by multiplying psi of x with the exponent of minus IET by h bar, represents wave propagation along x-axis. Then let the potential energy of the electron satisfy the equation. See what we are writing instead of V of x, we are writing V of x plus a. Okay, so V of x is written as V of x plus a. Okay, once already told, but then your understanding, telling again, A is set with period as such, and the Schrodinger's equation is given by d square psi by dx square plus 2m by h bar square E minus V of x times I equals to 0. That's the equation number 4. Okay, the small change. As I said, just compare. See, this equation 1 with equation 4 is see. D square psi by dx square plus 2m by h bar square E minus V naught times I equals 0. Whereas here, d square psi by dx square plus 2m by h bar square E minus V of x. Only difference E minus V naught, and it's been now written as E minus V of x times psi equals to 0. That's equation 4. And further, see, psi of x is given by e power plus or minus x, uk of x. That's equation number 5. And where uk of x is going to be the uk of x. Okay. Further, what we do is here, the block function that is defined actually. See, psi of x is given by e power of ix. uk of x has got the property. Okay, he wants to tell that there is a property called block functions, which is given by psi of x plus a, which equals to e power of ik times x. Instead of x, ik of x plus a be written. Okay, e power of ik into x plus a, uk of x plus a, which is there. E power of ik. Okay, that's the equation 6. Okay, this one, see here, you are supposed to do this derivation for about 4 to 5 times. If you derive it, then you can derive. That's what I'm telling you very clearly, because there is no other option. Okay, you must remember this. Okay, if you just go through online or just like that, scroll it on the screen, you cannot write it. You are supposed to practice it several times, then you can remember. Okay, so here psi of x is being given. What happens is here is a linear second order differential equation. Okay, and then there are two independent real solutions, that is g of x and h of x. We are naming it. Then psi of x is given by a g of x. Okay, the ABs are constants, of course. Okay, and psi of x is being given by a g of x plus b h of x. So what is this? How we have to understand this equation as psi of x is equals to, suppose if I say a g of x plus b h of x. So can anyone tell that what does this equation 7 is being understood? What do you think that equation is? Can anyone tell? Equation 7, please. Hello?
No, sir.
Yeah, see, you have here psi of x is equals to a g of x plus b h of x. How you have to understand is we have psi of x. Psi of x is a kind of a variation we are talking about. A kind of a variation of energy, or you can say amplitude, or whatever you think in your mind. Oh, psi of x is a kind of a wave function. Okay, along the x-axis we are talking about. And that wave function may be talking about some kind of intensity or any kind of amplitude we are talking about in a wave. Okay, that's contained. There are two factors. Okay, so which is g of x and h of x, that may contain something like two factors. That's what block has got. Okay, and APs are constants. Of course, we find them out. So it's a g of x, b h of x. Okay, and then what happens is here that you have to satisfy with the Schrödinger's equation. How I'll tell you. See, g of x. Now g of x has been written as g of x plus a. Okay, and is equals to some equation alpha 1, alpha 2, of course, they are constants, alpha 1 g of x plus alpha 2 h of x, and h of x plus a is defined as beta 1 g of x plus beta 2 h of x. Okay, an equation has been written. We have to solve this. Okay, how we will solve, I'll tell you. We have here psi of x plus a is equals to a times g of x plus a plus b times h of x plus a. Okay, and further what can we do is we have to substitute. So you have to remember this equation once again. Psi of 1 x plus a is given by a g of x. See, just compare this equation. Psi of x plus a is equals to a g of x plus a plus b h of x. Can you see equation 7? Hello? Can you see equation 7, please?
Yes, sir.
Yeah. Now
Psi of
see
x
this.
is equal.
Yeah, after eighth equation and before ninth equation, there is one equation. No. Now you come to see that seventh equation and this equation. What do you find? Just x plus a. Instead of x, we are having x plus a. Okay?
Yes, sir.
Yeah. Psi of x plus a times a. Instead of g of x, we have g of x plus a plus b h of x plus a. Okay? So further, what is being done? Psi of x plus a is being written. Okay? Here, in the previous case, just in equation 8, what we have written, here g of x plus a has been defined as alpha 1 g of x plus alpha 2 h of x. Okay? And h of x plus a is being given by beta 1 g of x plus beta 2 h of x. Okay. And further, what can we write? Alpha 1 times a plus, because g of x is there, okay, in the both places. So that is how we can write. Okay, that's directly written anyway. G of x, h of x has been taken as common. Okay, from the previous equation, equation number 8 has been taken here. Okay, substitute, simplify, and then take just shuffle it and take g of x and h of x common. Okay, further from equation 6 and 7. Equation 6, once again, have a look. Equation 6 and has got the solution here, 6 and 7. What can we write is psi of x plus a is equals to a. See here, already a, b constants has been introduced. Okay. Further, alpha 1, alpha 2 plus beta 1, beta 2 are also introduced. Now, one more constant called lambda has been introduced. Psi of x plus a is given by lambda times a g of x plus b h of x has been written here. Okay, and now we have to compare the 9th and the 10th equations and determine that lambda. We have to, you must be familiar with matrices. Okay, hello, are you familiar with matrices? Can you solve the matrices? Have you done anything like solving matrices? We have here set of equations, alpha 1 A plus beta 1 B is lambda A, or alpha 1 minus lambda times A plus beta 1 times B equals to, okay. And further, it is written, okay, taken A and B as commons, and further C. You have to put them, you have to solve it, okay, by putting in a matrix. What is this? A, B, C D. Suppose we have a matrix called A, B, C, and we have to find the determinant. Then what will happen? AD minus BC. When you multiply AD minus BC, that's what being done in equation 12, please. Okay. So what is being done is AD, that is alpha 1 minus lambda multiplied by beta 2 minus lambda minus alpha 2 times beta. AD minus BC is being done. And that's what the equation number 12 is come out. Okay. And further, we have to show this alpha 1 beta 2 minus alpha 2 beta 1 as 1. Okay. Then g of x, h of x solutions has been written here as like minus h bar square by 2m, then d square g of x by dx square plus v of x, g of x is e times g of x. Okay. And minus h bar square by 2m, d square h of x dx square plus v of x, h of x is e times h of x. Okay, these are 13 and 14 equations. Okay, that's what I said. It's a bit complicated, still needs loads of time to practice. Then you will understand this, remember this. Okay, equation now, we have to multiply equation 13 by h of x and equation 14 by g of x. And simplify it to get in this form, which is minus h bar square by 2 h of x d square gx by dx square minus g of x d square h of x by dx square equals 0. That's what it will come up. Then since h bar square but does not equals 0, so the term will become 0. And then that's the differential form as differential form. Okay, g double dash and g h dash exponential. And what is understood is g of x, h of x, g dash of x, and h dash of x for constant. Then we could write here g of x plus c, h of x plus c, g dash of x plus c, h dash of x plus c has been given by g x, h x, g dash of x, h of x, alpha 2 beta. That will be written as equation 16. Then from the previous equation 15, and from here we come to alpha 1 beta 2 minus alpha 2 beta 1 equals 1. And the from equation 12, that's equation 1, we have to find out x square plus bx plus c format is there. So from there you have to find out the plan minus c plus otherwise. So minus b plus minus c plus okay, that's so from there you can make out lambda 1 and lambda 2. This alpha 1 plus alpha 2 plus over alpha square minus 4 and so also lambda 2 alpha 1 plus beta 2 minus beta 2 alpha 1 square minus 4. Okay, so this is what the block theorem is all about. Yes. Okay, so this is what the block theorem is all about. Okay, so for this, that's what I believe. Please try to understand the concept. Okay, then what is the procedure Okay, then you can practice. Okay, I'll send you the notes. I've been telling, but I'm not sending. Sorry about this. Sending of notes. I'll send you this and this. I'll send you short. Okay, once this is being done, we will do. I will send you the notes. Okay, now without wasting time, mm, we will go to a very important question called the chronic penning model. Okay, the chronic penning model is also a very important question. Um, Typical question, just like how block theorem is. First, you have to understand the block theorem derivation. Then you have to go ahead and take block. Not other way around. Okay, you have to first follow the first because this has been linked up with the block theorem. Okay. First, you have to know that. That's why I have to use that one first. Then we have to understand the chronic penning model. This is what I'm telling you. I request everyone here, please try to understand, try to get some idea. That's what I'm trying to. Please get into it. It's actually topics. This one is very difficult. Open level, very difficult actually. But still try to pay some attention and try to know that what you are trying to learn first. Okay, get some idea. So these are steps. If you just start writing the derivations, to practice it, then you will gain two times, three times, right? Then only you will be in a position to write in the examination. Because this carries 10 full marks question, block theorem. 10 marks there will be. Chronic penny order, 10 marks. That's what I'm telling you. Please try to understand the derivation step by step. And if let us say if you mess up one or two steps in between, but if you know the further steps, you can just try to manage it. You can manage it, okay? And there won't be much of a reduction in points. If you, let us say if you have missed one steps, then we'll look for the procedure, step by step procedure. If there is one or two steps being missed, it will also they don't really much. Okay. Right, fine. Now chronic penny model. Okay, what is this chronic penny model? Okay, I'll tell you. We assume that here in this case, the potential energy of an electron has the form of a periodic array of square wells. Okay, periodic array of square wells. Okay, so how we have to see this? This also I will show you. Just share it. Yeah, this is product animal. Now, can you see this? Hello, can you see this?
Yes, sir.
Yeah, okay. This is a chronic penny model. Okay, then what you have to assume is that the potential energy of an electron has the form of a periodic array of square wells. See, as shown in the diagram, see, that's what the square wells usually represent as square wells. Okay, the square wells. Okay, one is following the other. So how we had to understand this? Already I told you that square wells in the sense that there won't be any kind of a well or something like that. No. So you have to understand this square wells as a kind of potential. Okay. See, electron has to experience some kind of a potential in order to reach, as you see, can you see B and A there? B, B, we have got A there. Okay, we have got 0, we have got A here. So let us say from the left hand side to the right hand side, the electron has to make a travel from the left side to the right side. Then it has to go from the left side to the right side. It has to come across the potential, okay, which is shown in the form of a barrier. That's how you have to understand the well as. It has to come across a kind of a potential. If the electron is having that potential, if that electron is having potential, then the electron may enter into the next value. Okay, that's how you have to understand, and that's how it has to transmit. It will be transmitting from one place to another place and having a period array. Array means a sequence of the wells being arranged in some axis. Okay, you can say that as an array. Even the lattice, as I told you in the introduction class, the arrays. Arrays are some kind of arrangement of lattice along a straight line. Okay, that's what we call it an array. So also here, like array of square ones. Okay, that's what just briefly understand about any more. So here, the period of potential is A plus B as we can see as this. When we touch the figure here, A plus B, that's what the potentials A and B there. Okay, and then baseline between 0 and A, for instance, if that is the case, then the potential is consumed to 0. So see, that means if the open region, that is the open region, it's lying between 0 and A, for instance, then the potential is assumed 0, otherwise infinity. So in the open place, it is 0, and in the potential, they see here, the other one, it will have. Okay, so that's the condition is. And in the regions such as minus b, a line between x, line between minus 3 and 0, the potential energy is taken as V naught. That means it has got some value. That means it is maximum as V naught as we take. Okay. Further, the Schrödinger's wave equations for the regions are given by d square psi 1 by dx square plus 2m by h bar square e psi 1 equals 0 for x lying between 0 and a. So how you have to understand this? Now this Schrödinger's equation has been applied to two regions. Okay, please see once again the figure. See, we have here how we have to understand is open and other one is closed. Okay, so for the open one, Schrödinger's equation. And for the outer ones, okay, we have the another set of Schrödinger equation. Okay, this square psi 2 by dx square plus 2m by h bar square and times e1 minus v0 psi 2 multiplied by psi 2 equals 0. So these are the first base equations. Okay, this you have to remember. Well, d square psi 1 by dx square plus 2m by h bar square e psi 1 equals 0 for x line between 0 and a. Okay, that is one. That's one condition. And other condition is if x lying between minus 3 and 0, and that's the equation. Okay, two equations. Okay, let's put in this equation. Then it is to be assumed that the energy of electron is smaller than V naught. Usually, isn't it? So you have to be, it's not like they have given and we have to follow it. I'll tell you, we had assumed that the energy of electron is smaller than potential. See, V naught is the potential which is on the plate. Okay, and electron is experiencing loads of potential from the force from the potential. Okay, and of course the potential or rather the strength of the electron, the energy of electron is much smaller. It is much smaller than V. So what happens is 2me by h1 square, 1 by alpha square, and 2m times v naught minus e by h1 square is theta. Okay, and that will be equation number. And the wave functions must be of block forms. Okay? The wave functions must be of block form because block form has to be taken and extended. This theory is the extension of block functions. Therefore, we have here psi of x is given by same as before. E power of I kx, t of x is been written as d square psi 1 by dx square plus 2ik du1 by dx plus alpha square minus k square times u1 equals 0. If x lies between 0 and okay, and further for the second is supposing the electrons are lying in between the region called minus p to 0, then this square by dx square plus 2ik du2 by dx minus beta square plus k square times u2 0. There's a slight difference between the fourth and fifth equations. Okay, and further u1 of x represents the value of ut of x in the interval x lies between 0 and a, and ut of x represents the value of ut of x in the interval x lies between minus b to 0, then has got solution. Suppose if you don't remember this steps and all, nothing to worry. If you could write fourth and fifth equations and write the solution straight away, no issue. Absolutely no issue. Then the u1 of x and u2 of x has got the solution. A power of I times alpha minus k times x plus b power of I times alpha plus k times x, and u2 of x is done by c e power of beta minus I k times x plus d e power of minus beta plus I k times x. Okay, these two equations are the solution. Okay. Basing on the block theorem, these equations has been written, and for the conditions being written, if u1 of x at x equals 0 equals to u2 of x at x equals 0, and u1 of x at x equals to a, and u2 of x at x, if it is the case, okay, we could write d u1 by dx at x equals to 0, which is d u2 by dx at x equals to 0, and further d u1 by dx at x equals to a, and d u2 by dx minus 3. And if you apply these conditions and solve, our target is to find out A, B, C, and okay, and further A plus B equals D, and so also the equations have been written here. I times of alpha minus A times A minus I times alpha plus A times B equals to beta minus I k times C minus beta plus I k times C, and A power of I into alpha minus K times A plus B minus I into A into A is equals to C. Further, this A, B, C, D, you need to we just rearrange this equation, taking A power of I into alpha minus K into A minus I alpha minus K times the coefficients has been written there. Okay, and further the put it in the matrix 4 by 4 matrix. Okay, you need to write like that. Okay, 4 by 3 matrix. Okay, and then solve this. Solve this to get this equation. See, this is the equation number 14. Okay, you have to put them. The coefficients all must be kept in this equation. Okay, and further you have to solve it to get this. By all means, you have to remember this equation 14. You must remember the equation number 14 and put some conditions. That's easy. The equation number 15 is achieved. And further, you need to, if you draw the diagram and all, so it will be quite helpful. And then how the transmission takes place. Okay, and P of sine alpha A by alpha A plus cos alpha A equals to cos K. And this is how the function of alpha A for P equals 3 pi by 2. Because see, if you just follow this exactly, that's it. Okay, you will be getting full marks. Okay, for the chronic Kenny model. Okay. Okay, so we'll get back into it. Yeah, this is the chronic Kenny model. Okay. Okay. Further, we will see what we have as per the textbook is concerned. What you have, it's not necessary that you have to see what they have given in your textbook. Suppose if you couldn't understand this, okay, then you can follow my notes. Okay, understand you, but the concept will remain same. Whether you follow this or whether you follow my notes, the concept will remain same, but the kind of presentation will be different from one. Okay, approach will be different. Okay, and further you can manage the condition band, the differentiations and all. Okay, that's what the target is. Most typical, usually I take the most typical questions so that you can have some exposure. The other things you can study, you can understand. Okay, that's what the thing is. And then we'll make some attempt to understand some of the elastic waves. I think, yeah. The time is not there. We can just have a look at some of the points. I'll tell you. Okay, in the next class, what we'll do is we'll have the magnetism and the superconductivity. We have the half of the things, to be honest, half of the things are being studied in your BS third year paper. I don't remember paper 3 or paper 4 somewhere. The magnetism, Langevins theorem, okay, Lamor's theorem, okay, the diamagnetic substances, the paramagnetic substances, okay, and these are all being studied in your BSc, okay, but still here we have Lamor's Langevins theory, okay, and there's a derivation, okay, instead of this uh, derivation, we will, I will tell you, and that will be easier, okay. Okay, in the next, yeah, tomorrow also I will take class from evening 6 to 7:30, and then uh, we will know more about magnetism and all of it. Superconductivity also quite interesting topics to uh, just at least write in the examination point of view. The superconductivity is easier rather, and as far as your syllabus is concerned? Yeah, just a moment.
Sir, magnetism and superconductivity is from third block or fourth block, sir?
It's the last one.
Last one, okay.
Yeah. See, this magnetism, you have some very typical derivations, just like how we are doing here right now. But the superconductivity, you should not lose it. It's quite easy. Okay, theory questions are there. Okay, type 1, type 2 superconductors are there, and about the types of superconductors. Okay, and AC Josephson effect, DC Josephson effect, compulsorily they will definitely give. Okay, those you should not leave it. That we will discuss. Okay, in the classes to come. Okay, and in superconductors, you'll have the um, mostly they'll be giving you in short some short questions like describe about the type 1 and type 2 superconductors with the examples. Okay, they'll be asking. And about the long questions, they'll be asking about the AC uh, Josephson effect and DC Josephson effect. They'll definitely they'll be asked. Okay, take any question paper, old question papers. Okay, you ask for papers. Okay, I'll give you. See, I had to spend some time. I'll give you the old question papers. Okay, where you can see some of the questions like here. Just now I picked up the block theorem and all. Okay, the block theorem has been taken. Okay, similarly, chronic penny model, the AC, DC, Josephson effect. Okay, and the Langevin theorem, they will give in the examination. Okay, and that's why I choose those questions. Then it will be easier for the students to understand the concept. Now, further, see, a little bit of time is left now. Then we will discuss some questions. Maybe like the I'll tell you.
Can you please share the notes today's explanation, sir?
Yeah,
We will note down and
today.
revise
Yeah,
ourselves.
sure. See, the problem with me is that see, I've got many other works, actually, college work I'll be doing at home also. So that's why I'm busy. Anyway, I'll try to send it. Today I'll try to send it. Okay, even though if it is late, but still I'll send it. Okay.
Clarity.
Yeah. Then
Sorry? Sorry.
ఉన్నదిలే ఎక్కడ ఉంది పో
గో అది నా కోడి గుర్తుపెట్టుకో
okay.
నాది
We will see here. That's a little bit of time. 10
ఇక చల్లరి
10.
యాక్టింగ్ చేస్తుంది బాగా
Hello, please. Hello, you. Please mute it. Someone. Hello, mute
వెళ్ళిపోయింది
your.
కదా అయిపోయి
Hello, mute your mic, please. Okay, so here, see, we have wave motion. It's in a specific heat. Okay, we have in specific heat. Hello, in the specific heat, we have the wave motion of one-dimensional atomic lattice, and so also in three-dimensional lattice. These generally they will be asking these questions in the examination. Okay, so lattice heat, specific heat. In this specific heat, we have this theory. Okay, and I'll tell you about the wave motion of one-dimensional atomic lattice. Okay, so what it is I'll tell you. Suppose we have one-dimensional lattice of atoms, so many set of atoms we have, and they're all moving towards the x-axis, let us say. Then the positions has been given as n minus 2, n minus 1, n plus 1, and n plus 2. Okay, and see, I'll show you the diagram. Let us say this is the case. That's how they are moving, for instance. Okay, from one place to another place, they're all moving as shown in the diagram. Okay, if that is the case, then we assume that the atoms are spaced at distances a from each other. They are being separated by a small distance a and having a mass small m. Okay, then it is assumed that there exists interaction between nearest neighbors. Okay, and the Hooke's law has been obeyed. Okay, Hooke's law is, what is Hooke's law? Stress is proportional to the strain. Okay, and when we are talking about the strings, we are talking about. Okay, and assuming that that kind of force has been acting here, it is acting, then we have to use those Hooke's law here. Okay, so in a crystal we are talking about. See, understand the situation. Not the same situation. See, the Hooke's law generally used for strings has been used here. We have to cautiously use the concepts of the uh, the things what you have used for the Hooke's law is different from what we are talking about inside a crystal. They understand that, please, that we are talking about a crystal. In that crystal, we are having some kind of lattices. There are lattices in the sense atoms or molecules. Okay, they are being separated and they are undergoing some kind of forces. Okay, towards the left hand side, towards the right hand side, towards the top, towards the bottom. There are some kind of forces being acting, and these forces are found to be like elastic. Okay, and that's why this situation has been compared with the situations outside, like maybe in terms of string, how much of stress has been applied, how much strain it has undergone, it's been compared. Stress in the sense like a crystal, when it is applied to a high voltage, then what happens? The crystal undergoes a kind of a stress. Stress in the form of voltage. It's hard to understand, but still, once again, when the voltage has been applied to a crystal, it exerts some kind of a stress on the lattice. Okay, this is what you have to understand. And see, that's what I'm doing. First, try to understand the physical concept before you enter into the concepts of derivation. Then, if you straight away take up the concepts of derivation, you'll never understand what we are. First, get into it. First, see that what is that introduction to this. Okay, understand what we are trying to make. What theory has been compared with what, why it is been compared, I'll tell you. Because it acts like some kind of forces. It acts like some kind of forces, and some forces will be always trying to go away from the source and again come back from that source. Okay, so there are some equal and opposite forces which are acting, and sometimes we call it as a kind of a spring. There is no such thing as spring, but still we refer to it as a spring of forces which are acting towards the left and towards the right, and assume and do the derivation. See, that's what already I told you, that these are also to be highly imaginative concept. Okay, so what you have to do is that the force acting upon the nth atom, for instance, n number, maybe like anything, n number can be calculated in terms of extension of two springs, which binds to it. Some springs are being attached. There is no physical attachment. Okay, don't think we got a physical string or anything like that. No. Instead we have the strings being assume that, okay, some force is acting towards left hand, acting towards the right, okay, some kind of a spring. Assume that they are some kind of forces which are acting to bring it back. Or rather, can we say it as restoring force? Okay, if that is the case, restoring forces are acting this way. That way. Some are forces acting towards to go back to the original position. Some will be acting to take it away from that position. So that's why we call it as swing. Okay, this swing is first, let us say, it's released. Then it comes back to the original position. That's like here also being compared. And further, the force, okay, and force constants being written here. Force is taken as beta times x n plus 1 minus xn minus beta times xn minus xn minus 1. And beta force is given by beta times 2 xn plus 1 plus x minus 1 minus 2x. Okay, and the Newton's laws used here. F is equals to x ma, and being written here the second equation. Okay, m d square xn by dt square is equals to beta xn plus xn minus 1 minus 2. Okay, this equation. Tomorrow anyway we'll do it. Okay, we'll continue doing this derivation. Okay, in the next class we will see how it works. I'll try to share this equation. Then you will understand the things much better. Okay. And tomorrow, as usual, like 6 p.m. I'll take the.
Sir,
Thank you.
can you please explain the how we present the answers in the examination?
Yeah,
Then
yeah, sure.
the Q's part we can't we can't remember, sir. That's why. Is there any that's a pattern to write the answers?
See, that's what I'm trying to tell all the students that see they are making efforts here. They're listening to the online classes. They're coming to the offline classes. And instead of doing all these things, they are unable to write in the examination. The reason is that's what I'm telling. The physics is absolutely different from the other subjects. Okay, whatever the theory subject. The physics definitely need a practice. Definitely need a practice. And that's what I tell sometimes that you don't even go to the examination without practicing it. Okay, see, 1 day, 2 days, sometimes people say that I am too busy, I'm working as a teacher, I don't have time, I will read for only for 1 day and write the examination, and there won't be any kind of results. Okay, there is no use in writing like that. Okay, there is absolutely, the professors will not have any mercy. Okay, they will always look at the question paper and look at your answer. Okay, question to answer they will check. Okay, for instance, see, if anything like, if let us say a 10 marks question, a derivation has been done and you have skipped some of them, okay, they'll have understanding, okay, anyway, the student has tried to written some part, okay, and some part has been missing. Anyway, instead of putting 0, they'll give 8 marks, okay, like 2 marks will be there, that's it. That's how. So, see here, all you have to do every time is to just put it on paper and derive. Start practicing it. Okay. So take the notes. I will send you the notes as much as possible. I'll try hard to send it early. Okay. And then you have to just keep on practicing it. For instance, just now I told you block theorem. Blindly, you have to practice it. Then you can write in it. Okay. See, separate. Already I told you that please separate the theory questions and also the derivative questions. What are theory questions? What are derivative questions? What are short questions? What are long questions? These you categorize. Okay. And then it will be always better to focus more on first theory. Focus more on theory questions. For instance, you have theory questions, I'll tell you. Diffraction. The diffractions you have, or maybe you can say lasers. Lasers also completely theory. No derivations. All you have to remember is principle. Okay, for instance, how the principle is, what the principle. Okay, diagram, just a diagram you have to remember, and draw the diagram and write the function. Okay, how does it function? Okay, what is the principle. And it's not like don't just end up with 3 or 4 lines. You have to write about 10 to 12 lines, something like that, and draw a diagram. Okay, and then if you write the energy level diagram, that will be quite impressive. Okay, and remember as a story, and you can fetch marks. That's what the hint I would like to give. All theory, for me actually, I always tell the students that do not let loose the theory question. First, in order to pass in the examination, give 100% practice to the theory. See, suppose if you are reading theory, that's what lasers I am talking about, for instance, or diffraction pattern you are talking about. Diffraction, see, quite easy, isn't it? When you're talking about diffraction, X-rays through diffraction or Louis method, it's quite an easy thing where the students does not pay much of interest and questions will be given from there on. Okay, so I always say that you first read a couple of times and remember the phrases. Remember the phrases, and the rest of the things you can write in your own words. It doesn't matter. But that sentences, if you write in one words and you can understand, but we cannot, we in the sense, the professors cannot understand, then the purpose will get defeated. It should not be like that. Okay, you have to write in such a way that everyone understands. That's how the own writing with the phrases, whatever the phrases which are there in the concept, you have to underline it. You have to remember. See, like that only I used to write in my exams. What I used to do is first read the concept one time, two times, and underline what are the important phrases there. Okay, sentences or anything like words, terminology. Those things must come. Okay, underline with pencil, and then remember as a story and write in it. That's what I used to do. Okay, and coming to the derivation, as I said already, that there is a system in understanding the derivations. Derivations also there is a sequence. First step, second step, third step. You don't have to remember 10 steps are there. 10 you don't have to mug up. Just three or four steps will be there. Those are certainly very important ones. Those you must remember. For instance, whether you have listened to class or not, I don't know. I talked about the career concentrations. Okay, I talked about. It looks very, if you see for the first time, it will be around 10 to 12, 14 or 15 steps. But if you could remember, if you focus, then you will have actually 3 to 4 steps only, if you remember. That is the technique. Okay, just 3 to 4 steps you remember, and rest of the things you can easily create on your own. Because if one follows the other, one follows the other. That's the sequence you have to remember and create. That's what the thing is. And don't just experiment. Do not experiment in the exam question. Please practice it before you go to the exam. First, you put it without seeing on paper, and then compare that where you have done the mistake. Then you can approach for the exam. Okay. Okay. In the next class, we will discuss
Sir,
more.
thank you, sir.
Thank you.
Sir, can you please send once again all that different type of questions, sir?
Yeah, sure. Questions? No, yeah. I'll send you.
Any possible notes are also, if anything is there, can you please
Yeah,
that
notes
also?
is everything I'll send. Everything I have, don't worry. Everything I have. The only thing is that some are there in my system, some are there in my tab. Somewhere they are all there. I will gather and send it. Okay.
Okay, thank you.